All right, machine learning. Apparently, a lot of people are interested in this. And so you're probably all like me. You've probably all heard about it. There's machine learning this, machine learning that. It's pretty much the new trendy thing in tech. Everybody's talking about it. Everybody wants to do it. Everybody tries to add some sort of machine learning into their new cool IoT thing. So basically, machine learning is almost like the new IoT. So, and there's many things that you'll hear. If you start digging into it, you'll see stuff about, well, machine learning, obviously, but there's also artificial intelligence. There's deep learning, neural networks, all kind of different algorithms, classifiers, genetic algorithms. But what does that all mean? And you'll see it everywhere. Like it goes from my thermostat at home to some chatbots that magically became Nazi racists and stuff like that. So you've seen all kind of different examples. And not only that, but you might have noticed as well that some of your applications, say your phone probably already gave you this. There's a notification that will pop up and say, oh, time to leave for work. But you've never actually specified to your phone where you work or at what time you work. But somehow your phone magically detected that. So more and more we'll see applications that will learn about our preferences rather than asking the users specifically what are their workplace or at what time they go to work and stuff like that. So machine learning is part of our life, whether we like it or not. And let's see how we can start to integrate them within our applications. So obligatory about me slide. I especially like to see myself like on a big screen like that. I'm a bit narcissistic. So that's one thing about me. I do a lot of mostly JavaScript programming. I used to do a lot of PHP, less and less nowadays, but I still have to use it every now and then. I'm a bit of a tinkerer as well. I like to play with stuff. I do mostly management now, so I don't do as much code as I used to do. So what I do during my free time is that I actually code and play with different things. And I really like new technology. So whenever I have the chance to learn about something new, I really dig into it, try to learn as much as I can, and then I try to teach it to people. So that's why I'm here today. I'm a technical director at Spiria, so it pretty much means that I do everything that nobody wants to do. And I was super surprised because I was walking into the city yesterday, and I should have brought the picture, but I saw a place in Amsterdam that's called Spirit, and they use exactly the same font, and it's white. So it's like super, anyways, okay. I wasn't sure if like it was a big thing that everybody knew about, but it was like basically the same logo. All right, what's our agenda today? We'll do a little bit of theory. We'll talk about artificial intelligence versus machine learning. I'll just drop a little line about deep learning because everybody wants to know about it, but it's a full different topic. So if what you really wanted to learn today is like how to build your own neural networks and stuff like that, might not be the best place, but you'll still get a little bit of an introduction. So what I want you to get at the end of this is to not be intimidated by the world of machine learning at the end. So we'll talk about different algorithms, supervised, unsupervised, and we'll go through an example of a naive Bayes classifier, which is one basic algorithm, and the genetic algorithm. So it's a lot of content. Hopefully we'll have the time to go through this, and we'll have maybe a 5-minute of Q&A. I understand it's the last talk of the day, so some people might be in a hurry to get back home. So we'll see how that goes. So let's get started. Artificial intelligence. If you Google it, you'll probably see images like that. Typically a woman, probably the intelligence part. Usually covered with like circuit boards and stuff like that, probably the artificial part, and usually some code. Do you see anything wrong with this code? It's jQuery. It's Bootstrap, actually. Probably not the best example of machine learning stuff. But anyways, artificial intelligence. Artificial intelligence is intelligence exhibited by machines. So in the field of AI research, we define it as any device that perceives its environment and takes actions to maximize its chances to success at some goal. So I'll put a little bit of emphasis on this specific part. So artificial intelligence is just a set of rules that will be used in order to mimic some sort of intelligence. So it's just a series of ifs, basically. What does it look like in the real life? That is one very good example. So each one of those ghosts, although you've probably all played PacMan, at least if you're my age, and you've tried it and you kind of have that feeling that they're all chasing after you and they have they're very smart. But actually they're very, very stupid. They follow very stupid rules. And they're all different. So Blinky, the red one, will just follow you. Doesn't really matter where you're at. It just tries to reach as fast as it can. Pinky kind of tries to predict your movement based on where you're headed. So I think it goes in the opposite direction. So it kind of gives you a feeling that it's trying to track you from another way. Inky's position will highly depend on Blinky's. And Clyde, interestingly enough, which is the orange one, will never catch PacMan. As soon as it gets close enough, it goes in a different direction. And that's the way it was built. And there's a reason for that. It gives an impression that Clyde tries to go another way to attack you, but that's not the case. Really, you can totally ignore him. So you're now PacMan experts. So if you got one thing out of this talk, seriously though, so it's just a series of rules, and they follow those rules to kind of mimic artificial intelligence. So that's what artificial intelligence is. Other examples in real life, more modern examples, would be credit cards, where they have like a set of arbitrary rules. Say a transaction is made in a foreign country, the card gets canceled. Happens to me all the time when I travel, and it's very annoying. But those are rules that are arbitrarily used in your software. Machine learning, on the other hand, is a subset of computer science that gives a computer the ability to learn without being explicitly programmed. So rather than programming the rules, we are programming a way for our software to learn the rules, right? So there are various examples. I have a Nest thermostat at home. I'm not sure if any of you have one. And I didn't mention it at the beginning, but I live in Canada. And we have very, very cold weather in the winter and very hot in the summer. So you kind of basically always have to retrain your thermostat. But when it comes fall or when it comes spring, my thermostat will just show up a message saying, OK, well, time to train me. And then I'll just adjust the temperature whenever it makes sense for me, when I'm at home or when I'm leaving and so on. And after a while, it just starts to set itself automatically just a few minutes before I come home. So the house is nice and cool during summer and hot and cozy during winter. So that's a good example of machine learning. So nobody actually programmed the rules into a thermostat. It just programmed a way for a thermostat to make its own rules. Siri, Cortana, OK, Google, and so on, they all have their own machine learning algorithms built in. I've mentioned the example of detecting when it's time to go to work and stuff like that. And there's also the very interesting case of Tay. So I'm not sure if anybody heard about Tay. Tay was a chatbot that was introduced by Microsoft about a year ago, just over a year ago. And some people heard about it. And she was meant to learn from her interaction outside in the real world. So they've deployed it over Twitter, and she would respond to both public tweets and direct messages. And when she got deployed, she was super stoked to be part of the human world. Very, very excited. That was on March 23rd at 8:30. About 12 hours later, she started not to be so happy about being with the humans. A few hours later, and it wasn't getting any better. That's 24 hours after it left, after it was launched. So they've closed it. But Tay, all in all, is a very, very good example of a machine learning algorithm. So it was basically a blank slate. She didn't know nothing, and she just learned from the interactions. When my mom saw that in the news, she kind of got panicked, and she said, "Oh my God, like the computers will dominate the world, and computers will want to kill us, and how can a computer become a Nazi?" And well, the thing is that it really learned from the interactions from humans. So really, you don't have to be afraid of machine learning, but be afraid of humans. So I kind of lost hope in humanity at that point. But it also makes you realize that it's very, very important that you add a defense mechanism in your algorithm, because there will always be trolls trying to find a way to exploit whatever you're putting out there. So be careful with that. Back to our program. Deep learning. So it's no surprise to all of you that there's a lot of data that is available out there. Everybody gathers data. Google gathers data. Whenever you're going on whatever website that you're going on, Facebook is, any single enterprise is probably trying to get some data from you. And they have all of this stuff and all of this data. And there's also all of those cute little kitten videos that get posted on YouTube and all of those weather data and all that scientific data. And how do you make sense of all of that? And there is no way nowadays to process all of that manually. You need to use new algorithms. Even with the typical computing that we used to do, which would just use a loop and see if there's a correlation between the number of visits on my website versus the weather outside, it's going to be very computing costly. So you need kind of new tools and new ways to do that. And that's where deep learning comes into play. And deep learning will typically use neural networks as well in order to learn and make sense of that data. Like I said, I don't want to spend too much time on it. But as a rule of thumb, basically it's just a way to break down data into smaller chunks and to make sense out of it. So in this very specific example, data comes in and it tries to detect if there's some sort of shadow patterns that it can kind of make sense out of it. And if it does, it goes to a next layer, it passes on that information. And the next layer will try to see if those shadow patterns are kind of a face, something in your face. And then if so, it will move on to the next level and try to detect if there's an actual face on the image. If there's two eyes, a nose, and a mouth, then it's probably a face, right? So neural networks is a nice way to break down into smaller chunks. There's much more to that, but I don't want to get into it. First of all, because I don't really know anything about it, but also because it's a whole different subject. If you are interested, though, there is TensorFlow, which is a very interesting open source library which runs on Python that you can use in order to build your own networks. And there's also a bunch of different cloud options now available, IBM Watson being one, and Google also has a cloud computing artificial machine learning thingy. It's probably not called that, though. All right, so let's look into some algorithms. We're almost there, actually. So there's two main types of algorithms in machine learning. The first one is the supervised learning algorithm. So supervised learning requires user feedback, as its name mentions. So it starts with no knowledge at all. You feed it data, and it will eventually get better and better at doing whatever it's meant to do. Now, it's completely useless if you provide it with invalid data or useless information. So it's really a garbage in, garbage out type of scenario. Tay is one good example of that type of feedback mechanism where we provided it with bad data and it eventually started spitting out invalid outputs. It's typically used in classifiers. So whenever you want to do something that will automatically detect if it goes in box A or box B, that's what you'll use. So it's a classifier, so it classifies stuff into different categories. It can be used for if you want to detect the language of a text, for example. So you can eventually start teaching your algorithm how to detect if it's in French or in English. That's one example that I'll show later on. It can also be used if you've provided with enough data. It can also even detect if an author of a book or an article is a male or a female, because males tend to use certain specific words more than women. So eventually you can teach your algorithm to kind of detect that type of pattern as well. So if you provide it with enough information, eventually it can detect pretty much anything. Unsupervised learning, on the other hand, is a little bit hard to understand or to explain. But it's an algorithm that doesn't necessarily require feedback. So you'll use it in the case where you don't really care what the whole reasoning is, or whenever there's no real right or wrong answer, but it's all like gray areas. So I'll try to show you examples later on that will hopefully make this a little bit more clear. So it's used mostly to group behaviors, to identify patterns. So if you're trying to kind of know, if you want to know what type of users are browsing your website, and it will kind of try to identify different patterns to give you that information. So that's mostly what it's used for. All right, let's look at our first algorithm. Whoever says machine learning says maths, right? So the Bayes theorem mentions that the probability of having A or B depends on the probability of A over B, which can be then converted in an easier way to read, and the probability of A over the probability of A plus 1 minus the probability of B over A times 1 minus probability of A, which can be simplified like this. So it's the sum of all the probabilities of A till I over the sum of all probabilities of... All right, that's not true. You don't need maths to do machine learning. That's one of the things that I learned. Well, you kind of need a little basic arithmetic, but not that much. So we'll look at an example that is a little bit more simple. So you know, we've all seen Forrest Gump. So you know how he says, life is like a box of chocolate. You never know what you're going to get. So is that true? Let's see. So say you have a box of chocolate. And you're allergic to nuts, right? So you don't want to pick one that has nuts in it. And you know that round chocolate tend to have less nuts than square ones, and dark chocolate have much less nuts than light ones. All right, so we can convert that into some maths in order to find out if a round light chocolate will have nuts or not. So we convert those percentage into decimals, and then we just do the sum of them. So 0.25 times 0.9 gives you 0.225, and same thing on the other side. And then you simply apply this simple formula, which is the Bayes theorem, and it gives you a 75% chance that light round chocolate has nuts in it. So don't eat it if you're allergic. Actually, if you're allergic to nuts, don't use that. Like, it's probably not safe. But still. All right, so all it is simply a very, very simple probability calculation. So in this case, we're looking at a very dead simple example, but that's all there is to it. It's only a calculation. Is there a probability that something is more X or more Y? So that's all there is to classifiers. All classifiers follow the same structure. Basically, there's a training method. In this case, I've named it classify. So you provide it some sort of input, and then you provide it a category. If you want to do something more complex, you can classify images. You can classify all kinds of things. It can be used if you want to check if there's a tumor into X-rays and stuff like that. Eventually, you can learn how to detect if is there one or not. All the magic goes into your classify function, the way you structure all of your data. Actually, I was wrong. All the magic goes into the categorize function. Categorize just gives you an input, so you provide it with something, and it will tell you in which category it fits in. All right, let's look at a demo. All right, so does everybody know Tinder? Nobody ever knows Tinder, right? Oh, there's one on the hand. Oh, I know Tinder, I know Tinder. Okay. All right, so it's an interface that looks like Tinder, from what I've been told. So we will simply slide a card, whether the text is in French or in English. And we'll try to teach this algorithm, and right now it has absolutely no data. So I've removed all of the data from it beforehand. So this one is in French, in English. All right, it'll just take a while. You know. Oh, actually it was pretty fast. So as you can see, it says that this text is in English. So it actually already detected that some of the words there are typically there's bigger chance that those words are in English than in French. So if we go on, it doesn't detect all of them for now. Okay. It'll eventually get better. Okay, so as you can see, there's another one. I could do this all day. Like, it's so much fun. Trust me, eventually it gets better. All right, so as you can see, it can now detect French. If we continue a little bit, it should get better and better. All right, so as you can see, it's getting pretty good right now. So that's a very simple way to use it, and it's a very good valid case for classifiers, so you can detect whether a text is in French or in English. So what does the code look like? It has to be super complicated, right? All right, so it's about 100 lines long. Okay, it's definitely not the most optimal. This being said, PHP is probably not the most optimal language to do machine learning as well, specifically not this one, just because I have to reload all of the data every time. So at one point, it would become really, really slow. But just for the purpose of this talk, I wrote this one in a simple way. So I may put my efforts into doing something which is a little bit hopefully readable than actually optimized. So like I said, you have two main functions, so train and categorize, and everything else is private. The other functions that are private is the cleanup, which I take some words, and I'll just make sure that there's no weird characters in there, and I ignore words that have less than 2 characters, and there's a bunch of small rules, but it's not very important. And save and read, and all that they do is that they will save all of that data into a file. So it will just take all of my dictionaries, save it into a file, and just read from it whenever I want to do a categorize. So my training function is essentially just storing all of that data into a big object. So I just put all of the words in there, and I increment, and I put it in the category that it was assigned to. And I just increment the count for each word every time that the algorithm detects it. So that helps if you have some words that can be used both in French and English in this case. Stuff like, I don't know, bon appétit can be used in both languages. Or even a sentence could contain the word JavaScript. So is it French or English? Then it's hard to say. But you will see that there is a better chance that it's in one or the other if you increase those counters. So that's all I do. I just build this small dictionary here. And then in the categorize, then this one is a little bit of a mess. So what I do is that I take the string that is provided to it, break it down into different words, do my cleanup function on it, just to remove all the useless stuff. And then I just give it a score. So for every time I check into my dictionary, is this word part of my dictionary? If it is, what's the score for English? What's the score for French? And then I'll just add. So I'll have a score for one category and a score for another one. And then at the end, I just spit out the probability of which one is the higher. And when I reach a certain threshold, I say, OK, this is the one. This is the category you're in. So obviously, after the first card, if you pick up an English card right away, there's a fair chance. But based on some of the calculations that are done there, it won't give you the right language right away. We'll try to make the data more flatten the data a little bit more so that it provides you with a better guess. All right. First algorithm done. That was easy so far. Sentiment analysis. Sentiment analysis is often confused as being a machine learning algorithm, but it's not. So it's just using a simple set of rules, so it's more artificial intelligence than machine learning. Why do I talk about it? Well, it uses the exact same type of classifiers, actually. But rather than using a dictionary that gets built up over time, it just uses a set of data that is already provided to it. And every one of those words will have a score associated with that. So words like awesome will have a higher score than words like I don't care. So it will eventually give a score to the string that you've provided to it. Typically, it's from +5 to -5. +5 being something that is super positive, -5 being something that is very negative. And it can be used often for PR agencies that try to get a sense of, what does the general public think of something. It's used a lot in elections. You'll see, people tend to favor blah, blah, blah. It will be done through sentiment analysis. If you want to do it, JavaScript, there's a NPM library that is available. And in PHP, there's a Composer library that is available as well. So you just install it. There's generally just one method that you can use. Just provide it with some text, and it will spit out a score. So it's very, very simple to use. All right, on to my favorite subject, genetic algorithm. Awesome shit. All right. Remember when you wrote your first Hello World, and you were like super excited, and you came back home, and you're like, look, Mom, I just wrote this program, and all those 12 lines of code, they spit out Hello World on the screen. And she was like, yeah, so what? Just type Hello World, right? It's like, no, you don't get it. Like, I put in so much time and so much. OK, genetic algorithm is the same thing. If you have a bit of free time, definitely try to program your own. It's super fun. And you show it to people, and nobody will care. So I will show you mine. Please fake it, or, All right. So how does that work? Well, basically, it tries to mimic evolutionary theories from Darwin. So you'll take a population of individuals, and out of that population, you will keep the best elements. So those that are the closest to the solution that you're kind of going for. After a while, after that, you will keep some random individuals that are not the top individuals. You will introduce some random mutations in there. Then you will take whatever those elements are, and out of those, you'll pick random individuals to create children, which will share some of the properties of the random individuals. And then magically, you end up with a valid solution. All right? If it wasn't awesome enough, okay, let me recap this. So you create a population of random individuals, keep the closest, keep a few random individuals, random mutations, random children, and magically you get a solution, right? In the real world, it looks a little bit like this. Dreamcatcher is an application that is developed by Adobe, and my team has worked a little bit on this one. So it will help you to create different models. Say you want to print a bike frame, and you can have different criteria. Maybe you want the one that is the most solid. Maybe you want the one that is the lightest. And based on those criteria, it will provide you different mutations, different structures that could be lighter or more solid and stuff like that. Same thing if you want to build a drone skeleton. You'll probably want something that is sturdy, but still very light. Right? Let's look at a demo. All right, so in this demo, what I did, So what I did here is that I've asked my application to find a set of 4 float numbers that would give me a sum of 200. All right? Don't try to figure out what's the use case for that. There's none. OK, so the only thing that I'm trying to do is let's find 4 individuals for which the sum is 200. All right, so what it will do is that it will throw up random numbers, do those random mutations, and so on, and eventually spit out an answer with 4 float numbers that sum up to 200. There you go. Thank you. Like I said, it's not impressive. OK, but the fun thing is that if you look at those numbers, they actually sum up to very close to 200. If I run it again, I'll get a completely different solution. And it will take a different number of generations. It takes anywhere between 100 and a few thousand generations before it finds the right solution. And every time it's different. So when I said that in this case, it doesn't really matter the solution, there's no right or wrong answer. The only thing that I want is a possible solution that would be close to whatever I'm looking for. And because it goes through all of those random solutions, it ends up with something that is close, but it gives me something different every time. Oh, and that's an interesting one. So as you can see, those two are the same because they shared the same parent. They shared, probably a parent somewhere, and it gave two numbers that are the same. Okay, so how does it look like? So genetic algorithms always have pretty much the same function. So let's ignore the setters at the beginning. Initialize will simply give me a random population. So in this case, I want 200 individuals in my population. So 200 arrays of 4 elements, right? One individual is an array of 4 elements. And initialize just fills up a completely random array. I have a function that returns me the best individuals, or the best individual in the whole array. So out of my population, I want to know which one is the closest, and I'll use that to see if I have a valid answer or not. And the fitness function is where all the magic happens in those algorithms. So fitness is a calculation to see how close am I to the real answer. So because I have a very simple case, I simply check whether A plus B, how close, or not A plus B, but A plus B plus C plus D, how close is it to 200? And it will return me closest to 0 will be very close to 200. If you wanted to find a model for a bike that is the lightest, that's where you would try to figure it out. So you'd calculate the mass of all the product that you've used, and is it close to the lightest weight that I want to get or not. And then I have functions to sort it by fitness. I have functions to mutate, which just basically randomly change one of the elements inside the individual. And I have the reproduce function, which just takes the first 2 elements and the last 2 elements from a parent and a mother, or a father and a mother, and creates a new children based on that. So my evolve function basically just iterates that over and over, and it will sort all my arrays all my population by fitness. I then take a few of the best elements, which I use to create a new array. I'll just introduce some random elements from the original array as well. And then I'll just let it randomly introduce mutations if needed. So there's a probability that there will be a random mutation there. And then I just fill the rest of the array so that I'm back at my original population number, 200 in my case, with children that are created based on random father and mothers. And that's it. So I just check whenever I want to solve it, I just loop and I just do an evolve on my population up to a point where I get a solution that is acceptable, and that's what you get. So you get a solution that is close to what you wanted. All right, because my example wasn't very mind-blowing, I'll use something that somebody else did. Hopefully, internet will be good with me. So in this very specific example, that's a group of students that tried to modelize and try to see if they could teach a model how to walk. So what they did is that they've took a model, they specified where are the joints, where are the muscles, what are what's the flex that the muscle can do, and based on that, they just ran a few models using genetic algorithms. Right, oh, we're almost there. So you see that after a few generations, it kind of starts to learn to walk. But it takes a while. And the fitness function in that case is the distance that is done, or how far can the creature, let's call it, can walk, as well as how straight it walks. Right. Yeah, just because it's so much fun, let's take a look at these. I like this one. All right. Yeah, it pretty much works. So that's the interesting thing. Some of the solutions that came out of that experiment were almost working, as you can see in this case. Eventually it falls down, but and that's why you need to introduce random mutations, because if once it gets into a state where it's kind of trying to do that, it'll kind of just try to get better at doing something like this. And you want it to start walking straight again. So you'll introduce random mutations which will help changing the direction a little bit and hopefully get a random solution that is a little bit better than what's happening right now. All right, I'm running out of time. Too much fun here. OK, so the structure of the code typically looks like this. So I've shown it into my IDE. All right, so what did we learn? Well, you all know the difference between machine learning and artificial intelligence. So you can now be a smartass and correct everyone that uses not in the right way. We've learned that I don't know anything about big data and deep learning. Supervised and unsupervised algorithms. And we've seen naive Bayes, sentiment analysis, and genetic algorithm. What I hope you'll gain out of this is not necessarily how to do it, but I hope that you won't be intimidated by it anymore. The first time when I really wanted to get into it and I needed to do something for an application, it felt overwhelming. It's very, very academic, all the stuff you'll find on Google. There's a lot of math involved. And as you can see, you don't really need to go deep into math. And you don't need to read all of the academic papers. That's all I had for today. Thank you.